The accompanying table shows the results from a test for a certain disease. Find the probability of selecting a subject with a negative test result, given that the subject has the disease. What would be an unfavorable consequence of this error? So, how many tested positive? Well, 357 plus 26 is going to give us a total of 383. How many tested negative? 18 plus 1,150 is 1,168. Now, how many said yes? 357 that actually had the disease plus 18 gives us 375. And how many hadn't had the disease where it said no? It was 26 plus 1,150 is going to give us 1,176. So if we add this last column or add the last row, it's going to give us the total amount in this survey, which would be 1,151. So again, we're coming back up here. We want to find out the probability of selecting a subject with a negative test result. So we're looking at the row for the negative test result, given that the subject has the disease. So yes means that they had the disease. So a conditional probability of an event is a probability obtained with the additional information that some other event has already occurred. So we would say that the probability denotes the conditional probability of event B occurring, given that event A has already occurred. So in this case here, we want to find what is the probability of a negative test occurring, given that the subject has the disease. So event A is the event which is known to have occurred. The given event is the individual has a disease. B is the event for which the probability is sought. This event is the individual tests negative for the disease. Now, the conditional probability of B given A can be found by assuming that event A has occurred and working under that assumption, calculating the probability that event B will occur. So we first need to determine the number of individuals who have the disease and then add the values in the indicated column. So this is a yes that has a disease, so we're going to take 357 plus 18, and that gives us a total of 375. So 357 plus 18 gives us 375. Now we can say that from the table, there are 18 individuals who had the disease and tested negative. So let's go back up here. How many have the disease and tested negative, you can see, is 18. So now we're going to divide to find the probability. So the probability that a person who tests negative, given that they have the disease, is equal to 18 over 375, which is equal to the probability of 0.048. Therefore, the probability that the randomly selected individual who has a disease tests negative is 0.048. Now, going back up to the second part of the question, says, what would be an unfavorable consequence of this error? Well, to determine an unfavorable consequence of this error, consider a subject that has a disease but with a negative test result. Note that a negative test result would lead the subject to believe that he or she does not have the disease. So the subject would not receive treatment and could spread the disease.